Hey everyone, in this video, let's take a look at problem 347, top k frequent elements on Leetcode. This is part of our blind 75 list of questions, so let's begin. So in this question, we are given an integer array nums and an integer k, and we want to return the k most frequent elements. You can return the answer in any order. So let's take a look at the examples that we have here. Go ahead and paste these examples here. Okay, so here we have nums. We can see that in nums, the number 1 occurs 3 times, the number 2 occurs 2 times, the number 3 occurs 1 time. So if you were to kind of sort this based off of just like the most frequent, then this would occur like this. We would append this because it occurs 3 times, so that goes here, and then this would also go because it occurs 2 times, so that would go here. And notice that we could have actually just returned like 2 and 1 here, so it doesn't really matter. All we really care about is the k most frequent elements, and kind of same thing here. K is equal to 1. Okay, so how might we go about doing this, right? And maybe something that pops in your head is like some sort of heap data structure, right? Like heap data structure, we know it's helpful for us because it'll always return to us either the maximum or minimum based on like the array that we feed it, right? So that might be helpful. So maybe something we could do is like we could put in all of these items into the heap, and then we could get back like whichever one is the largest one, and then maybe whichever one is the second largest, third largest. So that might work. But in order for us to do that, we need to like we can't just add like the same element into the heap, right? That wouldn't really do anything here. What we were really after is like the frequency, right? Like the count. So it would kind of make sense for us to really like count how many times all of these elements occur in nums. Maybe we have a counter. Maybe like we map like 1 to 3, which means 1 occurs 3 times, 2 maps to 2 because 2 occurs 2 times, and 3 maps to 1. And maybe we can actually put these items into the heap, right? Maybe we put like a tuple, like maybe we put like something like 3 and 1. And so here we would be like something like 2 and 2. Maybe here it would be like 1 and 3. And so we can maybe just pop like these from the heap. And so from this, we can understand that like this occurs the most often. And so we'll take in the value 1. This occurs the second most often. So we'll take in the value 2, etc. So maybe let's start off with that approach and see how we can code that. All right. So in order for us to even begin, we need to create a counter here, right? Like a mapping, a frequency mapping. So it's very easy in Python. We just create a counter. So this will exactly create us like 1 to 3, 2 to 2, 3 to 1. So it'll do that. Okay. So now we need to define our heap, right? So for heap, we need to import heap push, heap pop. So these are our two methods. Now we need our heap, which would be like this. Okay, now what can we do? Well, now how about we just throw everything inside of the heap, right? So we can do something like for item and then count in counter.items. So this will be like 1 and this will be like 3, corresponding to something like this. Let's just push this to our heap. So we will do heap push h, and then I can just push an item, or rather push in count, and then I push an item. So what's happening here is we're pushing count and item into the heap, and when the heap is like when you pop off the heap, it'll pop off the first element here, which in this case would be the counter. Now in Python, a heap is like a min heap. So if I was to actually do this, it would actually pop off this last element here because it's the smallest element. So actually I can improve this by doing minus counter, and this will be a max heap now. And so this is pretty much pushing everything onto the heap. And now all I need to do is I need to pop k times off the heap. So what can I do? Well, I can have my result variable here. I just return it in the end. And then I can simply do, well, k is greater than 0. Let's just pop from the heap, heap pop, from the heap, heap pop. And then I'm just going to take this first value here, right? Because it's going to pop me this tuple here, but all I really care about is this item here, which will be an index 1. And then I can just go ahead and append this, and this should be a working solution. So this is maybe a solution you want to start off with. And actually, one thing I missed is I need to decrease k by 1, right? Or we will keep going, basically. So let's go ahead and submit this. So this works. So what is the time and space of this? So time, if you think about it, so what is the time of this? So we're adding in n elements into the heap, right? So if you add in n elements, we're doing log n, basically, and we're popping out k elements. So it would be k log n, because the pop operation is like a O of 1 time. And so since we're doing it k times, we would have to do basically k and then times log n. So this would be the time, and space is just like O of n for the heap, right? Okay, so that's one thing. How can we maybe improve this? Well, if you really think about this, do we really need to add everything to the heap, right? Do we need to have everything into the heap? And if you kind of think about like what's happening here, let's assume k was something like, okay, let's assume k was 2, right? And we add in stuff to the heap. Well, let's assume now that we just want to do a min heap instead of like a max heap. Let's just do a min heap. So what can happen? Well, in the min heap, what will we have? Well, we will have 1 and 3 added, then we will have 2 and 2 added, and then what? Well, if I go to add in one more thing, right, then my k would become like 0, right? Because every time I'm adding on to this, essentially, like you can think of it as like my k decreasing by 1. So at this point, k is equal to 0. So if I was to add on to this, then I would add on the value 3, 1. But really, at this point, we can't really do that because then k would be negative. So what would we do here? We can maybe just pop here. So what would we pop? We would pop the smallest element. So we'd pop this element, and then we'd add in the 3 and the 1, right? We'd add in this element here. And now notice that, what have we basically done? We started off with a min heap, and every time we added in k elements, we would pop one element off, right? So on the k plus 1 element, we would pop one element off. And so what actually remains on the heap, if you think about it, is the maximum elements, right? Because in the min heap, we'll just keep popping off like the smallest element. And so whatever remains must be the maximum element. Let's think of it simply. Let's say like we have like, let's say k is equal to 3, and we add in like the following elements into the heap. And let's just say like we want to get like the maximum values back, right? So in this case, if I go to add in like the value 6 here, well, it won't be allowed because first of all, k is equal to 3, so I need to pop. So let me maybe add in the value 6, or maybe let me go ahead and first pop. So I'll pop the smaller element here, and then I'll add in the value 6, right? Now maybe I want to add in like the value 1 after this, right? So maybe there's like a 1 here. Well, what can I do in this case? Well, in this case, k is already equal to 3, right? So if I were to add in the 1, then it would basically just be popped out again. So in this case, like we still always have the maximum elements on the heap that's left. So let's take a look at how we might be able to do this. Okay, so one thing is that when we are adding onto the heap, so when we are adding onto the heap, we basically need to keep track of like what is the size of the heap, right? If the size of the heap ever becomes like greater than k, then we want to pop from the heap. So what can we do in this case? So we can do something like heap push. First of all, we'll add the element. So what we add, we'll add an h, and then we will add in the count this time, and then the item. Notice I'm not doing the negative count because I want a minimum heap in this time. Then I can check if length of the heap is basically greater than k. Well, then I would just pop from the heap. I would do heap pop h, and I don't really care what this element is because I know that it's a smaller one, so it's not going to be our answer. And then in the very end, all I need to do is I just need to pop everything from my heap. So here I will just do res.append heap pop, and then h, and then it'll be the first element, and I will declare my res over here. So let's take a look now to see if this works. I'll run my example test cases. And I forgot to do my k minus 1, k minus 1. So let me run this now. And then go ahead and submit this. We can see that this also works. So what are we doing here? Well, here kind of the difference is that at maximum, we're not actually adding n elements to the heap, right? We're adding k elements to the heap at maximum. So that would be log k, right? The size of the heap would be k, and then we're actually removing k elements only. So it would be like k log k if you think about this approach. This is kind of better than k log n. Here we are adding everything, but because the size of the array would essentially be everything. But here we only add a maximum k elements, and we're actually just popping k elements outside, right? So if you can think of it like that. Now, what about our last case? Like, what is kind of a case that might be a little bit better than this? Well, this kind of question, it would be useful if we use something called a bucket sort, and this is an algorithm that you probably don't know about. So I'll just go ahead and explain this algorithm. It's kind of a little bit hard to come up with if you don't really know the trick, but let's see how we can do it. But basically, the good news is that we don't need the heap for this one. But let's just kind of see if we can come up with this, right? So let's see. Well, if I have like this, I have like this set of numbers, right? So let me remove all of this. I have this set of numbers, and how many numbers do I have? I have 1, 2, 3, 4, 5, 6 numbers, right? 6 numbers, 6 nums. So if you think about this, at the maximum, I can have something like this. I can have one element, doesn't have to be one, but a single element, and it can have a frequency count of 6, right? I can have something like this. So what this basically tells me is like, what if I just store like maybe a dictionary? Let's call it a dictionary, and I can maybe just store 6, 5, 4, 3, 2, 1. I can basically store like how many elements have a frequency count of 6, how many elements have a frequency count of 5, 4, 3, 2, and 1. So in this case, what would the answer be? Well, 3 would just be 1 here, 2 would be 2 here, 1 would be this 3 here. And then what I can do is I can just go in reverse, right? And then I can basically just pop from these elements here. So for example, let's actually make this easier. Let's say there was something like, let's say maybe 2 also occurred 3 times, right? In which case I would actually have a 7 here potentially. And so here I would have something like this, 1 and 2, and then this would be empty. So if we had something like this, what could we do? Well, we could go in reverse, and basically, like if we notice a value that has elements inside, then this can be popped off, right? Like this basically means that like 1 occurred a maximum of 3 times, and it was a maximum, right? It was like one of the most frequent elements. So basically, I can reduce my k by whatever is required here. So let's say k is equal to 2. So I can traverse and reverse, and then here I can see like, okay, we have an element here, so k will now be 1, and my result will add in that element, which was just 1, right? And now here we also have an element, and so we can add that, and now my k is 0. So actually my k is now done, so I don't have anything else to do. But basically, like, you could go in reverse now. If k was something else, like let's say k was something like 3, and we had like something over here, then we could process this as well, and we can keep like working our way downwards to arrive at the answer. So that's like a bucket sort approach. So let's see how we might be able to do that. How can we do it? Well, again, we need our counter first of all. Shouldn't have delayed the counter. But what else do we need? Well, now we can have a dictionary, and I'll actually do a default dictionary of a list, right? And what do I want to do? Well, I don't actually need to start off with 7, if you think about it, because like it's a default dictionary, so I don't need to actually add in like 7, 6, 5, 4, 3, 2, 1. But I can actually just go from the counter. I can do for item count in c dot items. Now I do d at count dot append item. What are we doing here? In this case, we'll basically at 3, I'll append the number 1, and then at 3 again, we'll append the number 2 because 2 occurs 3 times, and then actually this doesn't have anything, and then this 1 remains as it is. Okay, so we have our answer there, and now I'll just create my result variable here, and I'll return result in the end. And now what do we have? Well, if you think about this, I can basically just go through this dictionary, but I have to start from like the last element, right? So I can do like for I in range will be nums, like the length of nums, 2, 0, and then -1, right? So here I'm basically traversing from 7, 6, 5, 4, 3, 2, and 1. I'm not traversing 0 because we can't have like 0. It doesn't make sense here. What can I do? Well, I can check. So first of all, I can check for item in d at I, right? So all of this will actually be empty. So most of this will not do anything. But if we do have elements, so we'll add it in here, right? So we'll add it in here. So first thing I actually want to check is I want to check if I can even add in elements, right? Because if my k is already used up, then I can't do anything. So I can do if k is greater than 0. If k is less than 0, less than, I guess less than or equal to, we can just do if k is equal to 0, then we can just return res, right? Otherwise, we can append to res this item, and then we can decrease k by 1. And so we actually don't need to even return res here. That would basically be it. And so we can keep going here, and we can actually just have return res. Doesn't matter. But let's go ahead and run our sample test cases to see if I made any mistakes. I don't think I did, but let me go ahead and submit. Okay, so this is another approach, and this is actually O of n approach because we're not using any sort of heap, and we're just caching the results. And it's O of n in terms of space as well because we're storing this in a dictionary and a counter. But you can see it's like a different approach of thinking about it. But just to basically say what I'm doing, we'll have a result over here, and we'll basically go in reverse, and then we'll arrive at the 3. Now, first of all, I can add this one because k is still 3, so I can add this one. Or let's assume k is 2 here, so I can add this one. And now k becomes 1. Then I add this one, so now k becomes 0. And then when we arrive at this, well, we can't even process this because k is 0. So then we'll just go ahead and return. But this is a bucket sort approach that is probably the fastest one in this case that we can use. Thanks for watching.